So today we're going to learn about E. So our goal here is say like I know what E is and how to use it. Okay. So there's some interesting things that happen in math. So one of them is our old formula here that we've used a couple times. Is we have this formula A is equal to P times 1 plus R over N to the NT. Now, some mathematicians like to have fun. And so what they do is they just like to play with numbers. And so one of the things that they play with is making things infinity. So let me just tell you, so scientists decided to, or mathematicians decided to, put infinity in and assume everything is 1. So what they did is they took this formula and they put a 1 plus 1 over parenthesis 1, and then they put an infinity for n and an infinity for n here. That's times 1. But the times 1 doesn't matter because it's infinity. And so we have this weird problem like this. All right. Now, infinity means it's an idea, it's a concept, getting bigger and 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 bigger, right? So the bigger number I put in the denominator, the smaller number we have. The bigger number I put in the power, the larger number that we have. And so we have this fight that goes up and down, up and down, up and down as we get bigger and bigger and bigger. And what they found out is that when we can actually put infinity in, which is a concept, not a number. The concept is they get bigger and bigger and bigger. And it turns out that at some point it stabilizes. And we get this value called 2.718 281828. So we just, 2.718 is what we call it typically. And they call this E. Okay? So E is like, so if you want to write this in your notes, E is like pi. Okay? Pi is 3.14, so on and so forth. E is 2.7182818, so on and so forth. So E is just, it's like pi, it's a number, but it actually happens in nature a lot, and so they decided, just like we gave pi a symbol, because pi happens in circles, and everywhere there's a circle, there's a pi, 3.14, and so E is the same concept. And so today we're just going to just scratch the surface with it. It's pretty easy stuff. So we're going to use a calculator to evaluate this, and so all E is 2.718 to the power of 4. That's all that is. And we can put in the calculator. Another way to put in the calculator is, oops, my calculator broke. Yeah, let me fix my calculator. Okay, so I fixed my calculator. All right, so here it is. So let me turn this on and clear this out and get used so you can see it. Okay, so there's this little yellow E here, so I can hit second E, and I'm going to get that E, and I can put a 4 in and hit enter and get my value. Or you can use 2.718, so 2.718 and then power of 4. Notice it's almost identical, we're just off by a little bit because it is rounded. So if you can use the E, that's great. I'd rather use that. But if you want to round it, that's also fine with me. So I'm going to write 54.598, so it would be 54.60 is the answer. Okay. Next here is which is growth and which is decay. Now growth is larger than 1 and decay is smaller than 1. And when we look at these, they both have E's in them, and so they both look like they're bigger than 1. But we got to remember one concept, and that is right here. So let me highlight it for you. Right here. Negative powers. Negative powers are actually fractions, and they don't write E's with decay without it. So this is really that. And so when we have a negative power, that tells us it is the decay. When we have a positive power here, that tells us it is the growth. Okay, and that's the key indicator, so that we know that this is going to be a graph that looks like that. This is going to be a graph that looks like that. Okay, because it's decaying, it's growing left to right. The final thing we're talking about today is graphing. Same steps as before. Step 1 is the asymptote. It is exactly the same as a growth function. You just put it in the calculator, just almost the same, like it's almost the same. So we have our asymptote right here. So when I plot this, we're going to go to up 1, and we have our asymptote right there. Step 2 is the XY table, and that means this value here is going to go right here, and then we do one up and one below, and then we put it in the calculator here. So I'm going to do that. I'm not going to write it out, I'm just going to put it in. So just to show you how to put in the calculator here, we have the E. So I'm going to hit second ln here, so the E. And then the X, we're picking 3, so it'd be 3 minus 2 parentheses plus 1. And then we get, so we put that in the calculator, we get 3.72. And then we're going to do it again and again, and then have our graph. Very similar to what we just did, almost identical. But I wanted to introduce you to E, my friend E. It's a very good thing to know, because if you plan on going in any type of science-related fields or math-related fields, you're going to have a lot of experience with E, because you use it all the time. And on your assignment, it tells you to Google it and look up more about it and share about it. So I think that's pretty cool. So, all right, let's try. Oh, I just went in one direction. I didn't go below. That's okay. It'll be fine. As long as you have that blue value on there, your graph will work out. So no big deal. So this is 8.39. Now you're always going to get decimals with these, and that's okay. So 1, 2, 2, and then 3, 3.7, and then 4, and then that's 3, 4, 5, 6, 7, 8. It's up there. Not perfect, but that's okay. Then we have our graph right there. Ta-da! Now this looks exactly like what we've done before. Now we're just getting decimals all the time, no matter what almost. And that's E. So it's on the calculator. It's 2.718, like pi, and that's how you use it. If you have any questions, let me know. Have a great day.